Hi, this is Abhishek Kapoor, student of Deakin University. So this is the project pitch for SIT210 Embedded System Development, Task 7.1. So in this presentation, I will take you through the project overview, the working of the project, the problem statement, the hardware requirements, how the project will be set up, the software requirements, the ethical concerns related to this project, and proposal for future extension. So let's go through. Moving on to next. So this is my project overview. So in this project, I am making a smart home surveillance system. It uses facial recognition to unlock the door and sends an email to the house owner via IFTTT that the door is unlocked with a real-time picture of the time who the person is giving his face to the camera. So if the house owner reply yes, if he knows the person, the door will be unlocked, or if he says no, the door will stay locked. So the problem that I have solved by making this project is I'm solving a. So after the project overview, I would like you guys to see the project artifact. So here's my project artifact. I have made a whole document explaining my overview of the project, the problem statement, the hardware requirements for the project, the software requirements, the design principles, prototype architecture, link to prototype code on GitHub, the code, all the libraries that I have used in this project, working model link to at the YouTube. So how I tested my project, like the testing approach I used, the user manual, like if I have to hand over my project to someone in future who has to continue the project, so a person should be well aware of the things that I've used before and the ethical concerns that this specific project has and that can lead. So, and proposals for future extension and the conclusion. So, explaining this project artifact, here's my overview. As you can see, as I told you before, also problem statement, hardware requirements. So, coming on to hardware requirements, I have used Raspberry Pi 3, Argon Particle, Raspberry Pi camera module, a relay module, solenoid pull lock, a breadboard, jumper wires, LED, resistor, a keyboard, a mouse, a monitor. So these were all the hardware requirements. So I'll take you through them first. So the components that I've used, you can see over here. So here is my Raspberry Pi 3. It has a camera module attached to it, Raspberry Pi camera, a keyboard, a mouse, and here we have few jumper wires. It's a relay, and then we have a solenoid lock, push and pull, and here we have the argon particle device, a resistor, few jumper wires again, an LED, and the Wi-Fi module connected to the particle device. So here what actually I'm doing is, so I'm making a facial recognition system that can be placed in any house, in any office. It's like a security system. So let's go through the code. So just before going through the code, I would like to share all the components that I have used. I have just shown you in the video that what components I have used, but for the like setup, like how to connect the Arduino with the Raspberry Pi and the relay module, all that stuff I'll be explaining later in this video. So coming to the relay, so you need a 5-volt supply to power up your relay as well as your solenoid pull lock. I'll show you a picture that can explain it. Yeah. So here you can see a Raspberry Pi, a relay module, and a push and pull solenoid lock. So you need 7 to 12 volt DC power source to power these two up. And one of the wires from the negative wire from the relay module will go into DC power, and the negative from the solenoid pull lock will go into relay. Moving on, here's my GitHub repository where I have provided all the code that I've used in this and how the code will work. I've explained all this over here. You can go through. So these three code files, code 1, 2, 3, are for the Raspberry Pi, and IFTT communication is used by particle argon to send a message and communicate with the owner by sending an email whenever the door is locked or unlocked, as I told you in the overview. So now I'll show you the working of the project first, then I'll go through with the how I accomplished this project. So first let's have a look at the working. That's my monitor. First let's go into the file. So before that I'll show you my code. Yeah, so here's the code 1. In this code, like, we have all the directories. So in this code what happens is, like, we take in the code 1, in the file 1, the system asks for a name, like what's your name, we enter the name, so that name becomes a variable, and then the Raspberry Pi camera turns on, and then it takes the 30 pictures of that person, and that's it for the code 1. Like, when we run the code 2, our second file, so in this file, it's for the, like, machine learning. So based on that 30 pictures that that the camera took of the person, so it trains the machine based on the 30 pictures about the person. Like, if a person is wearing a cap, if he comes in a new look, so the machine is trained well to recognize his face. So in the second code, machine trains the itself, and in the third and final code, when we run it, so the camera turns on, and camera the person comes in front of the camera, the camera recognizes the face, it sends an signal to the relay module, and at the same time to the argon particle, and then the relay module sends the signal to the door lock, and the lock unlocks. So what happens at the same time, an LED turns on connected to the argon particle, and then that LED sends the argon particle sends a signal to the IFTT via cloud, and then the person gets an email that the door has been unlocked at the specific time with the specific face and with the name of that person who has unlocked the door. So let us see the working. So this is my code 1. So we will run it. So as soon as I run the code, so I don't need to put the name because I have already fed the names. So it says name already exists. So coming on to my second code, there you go. So as you can see here, the names of different persons and 30 images specific to each person. So now it's compiling. Now the machine is training itself. So now you can see there are 6 people and every person has a number in front of them. Now the machine is trained with the 6 people's faces, and each person has 30 different pictures. So in our third and final code, when I run it, as soon as I run the code 3, see what happens over here. So the camera is on now, camera module on the RPi. You can see my hand over there on the screen. So if I show my face to the camera, just have a look at this log. So you guys saw that. Like as soon as I showed my face to the camera, the door was unlocked and the LED blinked, and then the Argon sent an notification to the IFTT, and in this way I got an email as well stating that the door was unlocked by Abhi. That's my name. So the purpose of my system is to enhance the security, and in future, like, we can add more modules in it, like a fingerprint sensor, and that could be a two-factor authentication as well. And the different components, I have already showed you all the components that I have used in this, and the operation as well. So that is my project for the SIT210 embedded system developments. So it's a home monitoring security system that you can see, and it can be enhanced with time. I have used machine learning in this. I have used Python for programming and C++ in the to program the Argon particle, and Python to program the Raspberry Pi, and the both devices interacts with each other through the via the web. So that's pretty much it. Unlocks the door and locks it back. Thank you so much. So as you guys saw in the working, so what happens is when we run the project, first I'll take you to the working of the project, and then later I'll explain how to accomplish that. So when we run the third and the final code, so in the first code, what happens is when we run it, the system asks the user to input their name. So when the user inputs their name, that name becomes a variable, and the camera turns on, and the camera takes 30 consecutive pictures in like 2 to 4 seconds of that person, and that's it for the code 1. Then when you run the code 2, in code 2 the machine trains itself by those 30 images that it captured earlier, so that if a person comes in like a cap or shades, the camera would recognize him or her. And in third and final code, so this is the initial setup that you have to do once only to get a new face feed in the system. Rest, like if your face is already in the system, you just need to come. If you stand by the door, the camera will recognize your face, and the door will just unlock. But it provides it's not fully securitized, as if a robber took you in front of the camera, your face, like he or she has a gun pointed at you, and the door will still get unlocked by your face. The camera can't detect like someone is holding your face. It will just see your face. That is one of the concerns, ethical concerns, security concerns that you should consider. And in future of this project, like we can improve that as well. Like we can add a fingerprint sensor as well, and we can train a machine in a way that it knows what's happening around it as well. Deep learning, machine learning, we can combine all of those. So when we run the third code, the camera turns on, we come in the front of camera, it unlocks. How it unlocks now? So the Raspberry Pi sends a signal to the relay module and to the Argon particle as well at the same time. So the relay module sends a signal to the solenoid pull lock, and it unlocks the door, and at the same time the particle sends an signal to the IFTT, and via IFTT the house owner gets the email that the door has been unlocked with the real-time picture of that face, like who has unlocked the door. So this was the working of my project, taking you through the software requirements. So you need to install Noobs on your Raspberry Pi, and to install that, in first place you need to format your SD card in FAT format, and then you need to download the Noobs file from the noobs.com and install it into your SD card. Plug the SD card into the Raspberry Pi, chuck a mouse and a keyboard as well to the Raspberry Pi, connect the HDMI cable to a TV and to Raspberry Pi and power it on. Don't do anything. The screen will boot up, the Raspberry Pi will turn on, and it will ask you, it will take you to the installation process. Just follow by the process, and gradually you will install the noobs. So this is our first step. To accomplish this project, you need to know the programming languages like Python to code for Raspberry Pi and C++ for Argon Particle, a bit of machine learning as well to train the machine. And to train the machine, like, you need to download like OpenCV. That's a big file, so you need to have a lot of space on your SD card left as well, and a library that the Raspberry Pi camera works on as well. So these are some of the hardware and software requirements of the project. So this is the design principles, you can go through it. This is the prototype as I saw you. Testing approach, as I told you, like, it takes 30 images and all that stuff. So a user manual, ethical concerns, the data should not leak, as I told you. So I'll take you to the code. Jesus. So this is my code 1. So see, I have from picamera.array import CV2, that's the OpenCV. This is for Raspberry Pi camera. The camera resolution is set, the frame rate is set. So this is the file you need to download before you proceed and run the code, and I have included all that in my GitHub repository. You can take all the files. So it says what name, if the name exists, directory created, else name already exists, and it stores the 30 images taken. If the count is 7, break stores that images in that particular variable name. That's it for the code 1. Going through code 2, that is for the machine learning part. So as you can see, that file is being used again. A tester file is also created. So this is the code to train the machine. So the machine trains on itself, we don't need to do anything, but you still need to know how to train the machine, the code, how to write the code. If you're new to machine learning, I'll put a tutorial video how to learn machine learning for beginners as well. And for code 3, so this is the code 3, and you can see that if the image matches the person's name stored in the device, it unlocks and sends a signal. So see, in the readme file, it's like a user manual, like you can get to know how to run the project and all that stuff. For the trainer YML, you don't need to create it. When you run code 1, 2, so it creates on itself, and it stores all the names, all the photo images, all the in a dictionary format, and it has all the x and y axis of every pixel, every picture. So that's nothing to do with you. It will create a known when you run all these files. And so I'll show you. This was project
Working of the
overview.
project works.
Working
So the
of project, problem statement. So
the problem that I have solved by making this project is I'm solving a problem of privacy and safety that one has regarding his or her house when they are physically away from it. So this project solves a real world problem, and one can be anywhere in the world but can see their house live with the camera every time. So this project gives a satisfaction to the house owner that if there is attempt of burglary, so the house owner can take a action. She can have the real-time picture of the person entering the house, and they can give it to police. The hardware that I have used is Raspberry Pi 3.
So that I've told you earlier only. The hardware requirements,
The hardware. So here's the
the
setup of my.
setup also I've shown you earlier,
So here's moving on to
and the software requirements also I've shown you.
moving.
So these are the ethical concerns.
So these are the ethical concerns related to the project. If the data is leaked or somehow the machine gets hacked, the data has a privacy issue, and that's a real concern. And the door can also be unlocked by showing a person's picture in your mobile phone or a current picture. That also opens the door. So this should not happen. So in the future, so this is the proposal for future extension of this project. So we can add two-step authentication can be added, and to enhance the security, we can add a fingerprint sensor along with the facial recognition, and the machine will be trained well in a manner so that it can distinguish between a picture and a real person, so no one can unlock the door by showing a picture to the camera. And a mobile friendly app can also be made accessible. um, this was my project. Thank you so much.
So at the end, like I would like to tell you, for all the things that I've used, all the code, all the like project artifact, all the file, I'll be providing the links, project demo, the code files, and all this stuff, GitHub repository link. I'll be including all of them, so you can just have a look, and don't forget to let me know like how was the outcome of your project, like what new functionalities have you added, how have you been able to make it more secure, more convenience, more reliable for the consumer. So I'll be really happy if you share with me. So thank you so much for listening to me. Hope you guys liked my project idea. Thank you.